So hi everyone, my name is Kavinesh Reddy and I'm from Group 3. So now let me explain about how memory get allocated to process, starting with the two main approaches, which is fixed and dynamic partitioning. In fixed partitioning, main memory is divided into a set number of partitioning of fixed size. Each partition holds exactly one process, so the number of partitions limits how many programs can run at once. The problem is if a job is smaller than its partition, the leftover space inside the partition is wasted. This is called internal fragmentation. Dynamic or variable partitioning fixes this by allocating memory in exact size a process needs. As a process come and go, memory gets carved into holes or blocks of free space scattered throughout. This avoids internal fragmentation but creates a new problem. So the external fragmentation, where there is enough total free memory, just not in contiguous block big enough for a new job. Now, when a process arrives and we need to pick which hole to place it in, we use a placement algorithm of two of these, which are next fit. Which are next fit and worst fit. So next fit works just like first fit. It scanned the first uh, hole big enough to fit the job, but instead of always starting the search from the beginning of memory, it started from the where the last allocation left off. So it just keep moving forward through memory, wrapping around if needed. It's efficient because it doesn't waste time rescanning memory. It just checked, but it cannot still leave a job waiting, even if a suitable holes exist elsewhere. Uh, while worst fit takes the opposite approach from the best fit, instead of finding the small hole that fits like best fit does, worst fit deliberately allocates the largest available hole. The idea is that by using the biggest hole, the leftover space after allocation will also be large and hopefully still usable for future jobs. But in practice, worst fit requires searching the entire list of hole every time, making it slow, and it doesn't actually manage memory efficiently. A job can still foster to wait even if plenty of total memory is free, just not in one large enough block. So overall, fixed partitioning is simple but wastes memory internally. Dynamic partition is more flexible but suffers from external fragmentation. And among placement strategy, first fit and best fit generally outperform worst fit in both speed and memory utilization. And thank you.
Greetings, doctor, and everyone. My name is Shin Wei Yao, and today I will be presenting the real-world scenarios of next fit and worst fit memory allocation algorithms. So let's begin. A real-world example of next fit can be found in cloud data centers, where thousands of virtual machines and applications continuously request memory from the operating system. In this environment, the system must allocate memory quickly because many requests arrive every second. Instead of searching from the beginning of the memory list each time, NextFit continuous searching from the position of the last successful allocation, and this reduces the search time and improve the allocation speed. Therefore, NextFit is suitable for systems that prioritize fast performance, such as cloud servers, web hosting services, and virtualization platforms. However, because it does not examine each available memory block, it may not always choose the most efficient block, which can lead to higher memory fragmentation over time. Next, let's look at worst fit memory allocation. A good example is a high performance computing server where applications such as AI model training, scientific simulations, or a big data analysis require very large amount of memory. In this situation, WordFit always allocates memory from the largest available memory block. By choosing the largest block, it tries to leave larger free spaces after allocation, making this easier to accommodate future last processes. This strategy helps reduce the creation of many very small memory fragments, and it is useful when the system frequently handles large memory requests. However, repeatedly using the large uh, block may eventually break it into smaller pieces, reducing the availability of large memory blocks in the future. In conclusion, NextFit focus on faster allocation speed, while WorstFit focus on preserving larger memory spaces for future processes. The better algorithm depends on the system's workload and memory allocation requirements.
Hi, I'm Li Peiyuan. Now I'm going to compare two well-known algorithms, NestFit and WasFit, by using the interacting simulator. To ground the project in a real-world scenario, we have modeled our system as a data center, allocating memory payload into server rack. For today's scenario, we have configured 5 memory blocks representing server rack in our data center, and each memory block has different size for demonstration. And we also provide 4 different size process as our data payload for our demonstration. So we will begin with the NestFit allocation. For NestFit allocation, actually it will start the first process. It will start as the first in first out allocation. So we will find out the first. We will scanning and find out the first suitable memory block and fit it. But the interesting part is the second process. It will start from the last allocation point, which means is it will start next to the first process memory block. So here is the label that the second process will begin. So we will start from B3 and start searching until we find out the suitable block. So for the advantage for the NestFit allocation is it does not waste time scanning from the very beginning every single time. But the advantage is it creates fragmental gap at the beginning because the NestFit pointer keep moving forward. It rarely goes back to the yearly server rack. Any small space that open up, they are ignored, leading to resource fragmentation at the front. So let's move to the WasFit allocation. So the WasFit allocation is it always allocated to the largest available block. So it was scanning all the memory block and label the largest one and fit the process with the largest one memory block. So for example, it will scan and label it, label the largest memory block and finally fit the process. So the benefit is the leftover space is usually still quite big. This means the remaining space is large enough to easily host other incoming data payload later. But the disadvantage is every time a new data payload arrives, the algorithm has to scan and compare every single server rack in the data center to find out which one is currently the largest. This will cause the overhead happen. To wrap up, looking at our final comparison table, both NestFit and WasFit end up with the exactly same success rate and the memory usage. This proves there's no single best algorithm. It is always a trade-off. NestFit gives you speed and save computing power by moving forward. WasFit keep remaining space large to avoid tiny wasted fragments. Thank you.
Hi, my name is Kavinesh Analaki Batumalai. Now, I'll briefly summarize our project. Our project is a contagious memory allocation simulator that compares two operating system memory allocation algorithms, which are NextFit and also WasFit. User can enter different process sizes and the simulator allocates them into available memory blocks using the selected algorithm. It then displays the allocation results, remaining free memory, memory utilization, and also allocation state so user can compare the performance of both algorithms. Now, let's look at the operating system concept behind it. The project demonstrates contiguous memory allocation, where each process must be placed in one continuous block of memory. It implements the NextFit and also WasFit allocation strategy, while also illustrating important concepts such as external fragmentation, allocation failure, and memory utilization. This concept helps users understand how different allocation algorithms affect memory management efficiency in real world. Now, let's look at the real world application behind this. NextFit is commonly used in cloud data centers because it provides faster memory allocation by continuing the search from the last allocated position. WasFit is more suitable for high-performance computing environments where preserving larger memory blocks is more important for handling large applications. Overall, these examples show that different memory allocation algorithms are chosen based on the performance and also the memory requirements of different systems. That's all from us. Thank you.